Okay, g'day everybody. This is the third in my series of videos about vectors, and in this video we're focusing on magnitude of vectors and unit vectors. Okay, you see right here 4 different vectors. How long are they? The magnitude is the size. So really we're asking how long is it? Well, if I just gave you this on a graph, you could say, well, I'm going to form a little triangle here, and using Pythagoras' theorem, vector P is the square root of 2 squared plus 2 squared, because it's 2 boxes by 2 boxes. Okay, and then we're rationalizing that little surd there as much as we can. See a couple of things here, vector P, and we use these modulus signs, these absolute value signs, to signify the magnitude or the length of the vector. Okay, I'm going to give you a second to see if you can work out the magnitudes of Q, V, and W. See if you can do it. Pause the video. Okay, here's the answers. Q is exactly the same length, even though it's a different direction. There's V. That's a 3, 4, 5 triangle, useful to remember. And W is 2 root 5 long. That works for 2-dimensional vectors. It also works for 3-dimensional vectors. I'm not going to prove that for you here. You can try and work that out for yourself, why that works, but it's a nice little proof to investigate. But just trust me that it works for 3-dimensional vectors as well. I'll show you an example in a minute. We also got to talk about unit vectors. Unit vector is the same direction as a vector, but of length 1 unit. You can see here, there's vector A. This is another vector that's exactly the same direction, but its magnitude is 1. With unit vectors, we denote them like this, and I say A hat. Okay, this is vector A hat. Okay, there's the formula for getting a unit vector. It's the vector divided by its magnitude. For example, it's vector 3, 4. The magnitude of that is 5, so the unit vector is 3/5, 4/5. Now just to check, the magnitude of A hat is 3/5 squared plus 4/5 squared. Take the square root. And when you do that, you get 1. Awesome, it works. Here's 2 questions. One, you pause the video now and see if you can do them. Then I'll give you the answers. Okay, vector P is 1, 3, so the magnitude of P is root 10. The magnitude of 3P, well, 3P is 3, 9. When you square, and you get the magnitude of that, you get root 90, which is 3 root 10. Hey, look at that. Magnitude of 3P is 3 times the magnitude of P. Interesting. Remember that. Okay, find the magnitudes of these 3 vectors, and I'll just pop up the answers for you. Okay. 2 more questions. Find the unit vectors for these 2, and then I had question number 4. Pause the video, have a go. Okay, here's the answers for number 3. If the magnitude of P is root 10, so the unit vector of P you can write as fractions inside the brackets, or you can take out the common factor there. And so it's 1 over root 10, 3 over root 10. If you want, you can rationalize the denominator, but I haven't done that here. Magnitude of Q is 3, so they're nice fractions, so I'll just write 2/3, negative 2/3, I want that. Okay, find a vector V that's the same direction as P, but length of 4 units. Well, P is 1, 3. P hat is going the same direction as P, and it's 1 unit long. So the vector that's the same direction as p hat, that's 4 units long, it's just going to be 4 times p hat. Okay. The unit vector is 1 unit long, so a vector that's 4 units long is 4 times the unit vector. 4 times 1 unit vector is a vector that's 4 units long. Okay, and I've written it 3 different ways there, even rationalized it for you. Hope that was helpful. Stay tuned for the next video.